Namaskar and welcome to StudyIQ. I am your friend Rahul Saigaonkar. After a short breather, today we are continuing with our discussion of NCERT Science series. Till now, we have completed NCERT Science textbook for class 6, 7, 8 and 9. Class 6 and class 7 have been completed in bilingual format and are available on the main channel StudyIQ IAS. Class 8 and class 9 have been completed in English on our new channel StudyIQ IAS English. I have put all the videos so that you can watch them together in a playlist with this ID at the rate Rahul Sai 222. If you search this plus NCERT series, you will get the playlist that I have created. I'll also be sharing the playlist on the same ID. My social media handle is also same, Rahul Sai 222. I post it time and again on my Instagram page as well. You can always go there and check it. As I told you, today we are starting the discussion for NCERT textbook for class 10, and we will be following a similar format like what we have been doing for the other texts. We will be doing chapter by chapter analysis. So this is the index of class 10 science textbook. There are 16 chapters, and I'll be referring to the old textbook. You do know that the science textbooks, not just science, the other textbooks also have been rationalized by NCERT. I'm not using the rationalized version, I'm using the old version itself. There are 16 chapters in it. Today we will be discussing about chapter 1, chemical reactions and equations. In fact, if you look at the index, you'll see that the first 5 chapters, they will be focusing or they will be helping you in gaining basic chemistry knowledge. Today we'll talk about chemical reactions and chemical equations. We will be skipping out the parts which are not required for us from UPSC perspective. I always repeat that this discussion is from the point of view of UPSC preparation, not specifically about NEET or JEE, because there you need preparation about numericals, you need some formulas, you need other things as well. Here we will be focusing more and more on understanding chemistry from the perspective of everyday life, what we see around in our life every day. So let us begin chapter 1, chemical reactions and equations. But before that, there is a small notice for all of you. Those who are preparing for UPSC Civil Service Examination, StudyIQ is offering P2I, Prelims to Interview program. This is the most comprehensive program where we will be hand-holding you through all the 3 stages, Prelims, Mains and Interview. We will be helping you in strategy building, we will be guiding you, we will be completing your syllabus. There is prelims test series, there is answer writing practice. If you clear your preliminary examination 2024, you would be called to StudyIQ Center, where you would be honing your answer writing skills. You will be there for around 100 days, continuously practicing answers with the mentors and the faculty. This entire program has been designed at a very affordable price, and to get maximum discount on this, you can always use my code Rahul Live. The admissions are closing in a couple of days. 12th July is the last day to get yourself enrolled. Do it soon. I'll see you in the class. Right, let's begin. As I told you, today's discussion is about chemistry, chemical reactions. And in our previous interaction in 6, 7, 8, 9 discussion, the textbooks of 6, 7, 8, 9, we have gained some insights with respect to chemical reactions. And we have established that throughout our day-to-day activities, we see so many chemical reactions. For instance, right now, I'm breathing, I am inhaling air, and oxygen from that air is used for breaking down the nutrients. That is also a chemical reaction. It's a kind of exothermic reaction. Or there is combustion reaction, right? Every day you go to your kitchen and you simply switch on the gas. What is happening? The gas is burning. Combustion reaction is happening. You open a bottle of Coke or Pepsi, fizz is coming out. What is happening? Some sort of chemical change is happening and a gas is released. So many reactions. You simply add lemon to your water, add lemon somewhere else, there is some sort of chemical reaction which is occurring. We have also established the nuances between physical changes and chemical changes. We have established that chemical changes are irreversible. Physical changes, for example, water changes its physical properties. It is available in liquid format, in vapor format, in the solid format as ice. It is simply changing its physical characteristic, but chemically it's not changing. So we have understood the nuances between them as well. So in our day-to-day activities, the chapter starts with this itself. Consider some following situations. Say you leave milk during summers at room temperature. What will happen? There is a high probability that it will get spoiled. And if it gets spoiled, that means there is chemical change occurring in it. If there is an iron or iron tawa or a pan or a nail, you leave it in humid atmosphere, what happens? There is a possibility of corrosion, rusting happens. And what is this rusting? This rusting is a chemical change, chemical process. As I gave you example, simple breathing exercise or breathing is also example of chemical reaction, chemical change. The food that we cook, what happens when we cook food? We are giving it some heat and chemical changes are occurring. Grapes, they ferment. Grapes ultimately turn into wine, right? How is wine prepared? From grapes, from fermented or grapes, when they are fermented, you get wine. So that is again a chemical change that is occurring. One chemical compound changing into another chemical compound, that is alcohol. So day-to-day life, we see so many chemical reactions: combustion, rusting, digestion, photosynthesis. So many examples are there, right? Now, what is this chemical reaction? How do we represent them? See, chemical reaction is a process in which there is an irreversible change. The reactants, they react with each other and a final product is produced. And that final product will have different properties. All right. So a chemical reaction where the reactants, and we always represented the left hand side, we represent through reactants. So reactants, they react with each other and a final product is produced where the reactants act chemically. As I told you, a simple example has been put here where you prepare a cake. Now to make a cake, what do I need? I need flour, very fine wheat flour. We call it maida, corn flour, wheat flour. We need eggs, milk, sugar. We add all these things. We put it in the oven. That means some sort of agent is also given and it transforms into cake. So food that is cooked, it is an example of chemical change, chemical reaction itself. So you see, in a reaction, the reactants are seldom recovered. So one of the ways of telling that there has been a chemical change or a chemical reaction is to look at what has happened to the original reactants. Can they be recovered or not? And many times they cannot be recovered. For example, here we are preparing a cake. The reactants are oil, egg, milk, sugar, flour. We have mixed them and these reactants have ultimately led to a product of cake. Now, can I recover the reactants back from this cake? The answer would be no. So one of the ways is to understand what has happened to those reactants. They have undergone chemical change, which is irreversible. And that is what we established in our previous discussions as well, when we understood the nuances between physical change and chemical change. I gave you an example of water. Water transforming from liquid state to ice, say solid, or liquid to gas. It is simply a change in the physical state. There is no chemical change in it. But whenever there is a chemical change, it is irreversible. Apart from this, whenever there is chemical reaction, there are certain other characteristic features which we can see. Whenever there is chemical change, there might be a possibility of change in state, meaning solid turning to liquid, liquid turning to solid, or some sort of precipitation might occur. There might be change in color. There might be evolution of gas. I gave you an example of Pepsi, Coca-Cola. Simply open the bottle, carbon dioxide is released. Some reaction has occurred and carbon dioxide is released. Many a times in many reactions, we see hydrogen gas also being released. There can be change in temperature depending on the type of reaction, whether it is endothermic or exothermic. So as I told you, chemical reaction, they lead to either change in state of substance, say precipitation might occur. There are many examples of precipitation in your chemistry labs. You must have seen. Add two chemicals, one of them, it forms a compound and precipitates after undergoing reaction. For example, copper sulfate, when mixed with sodium hydroxide, it leads to precipitation of copper hydroxide. It settles at the bottom. There are many examples of precipitation, either change of state, or you can also see change in color, or any of these mix and match also. Now we have seen this example in our previous NCERTs also. Simply take an iron nail, add it to copper sulfate, aqueous solution. Now this is how we describe a reaction when we write a chemical equation. Then we write S for solid, AQ for aqueous, or L is also written as liquid. So iron solid is added to copper sulfate, aqueous solution. It is blue in color and displacement occurs. Copper is displaced by iron. And now this ferrous sulfate is formed in aqueous solution. It is pale green in color. Or there can be some sort of evolution of gas. zinc, when mixed with sulfuric acid, it leads to release of hydrogen gas. There can be change in temperature depending on whether the reaction is endothermic or exothermic. If the reaction is endothermic, then there is reduction in temperature. If it is exothermic, then the temperature will increase. Or there can be some sort of odor or smell because of, say, gas itself. Now, in our day-to-day life, we can see the example of egg. Now, have you observed a characteristic smell or odor of egg? When you prepare, say, omelette, you break the egg, you prepare the omelette, and you simply keep the eggshells on the kitchen counter itself. You forget it, say, for a day or two, and then you will observe a characteristic smell coming from it, spoiled egg smell. And that smell is of a gas which is released because of chemical change, that is hydrogen sulfide gas. So any of these things can occur. Now, this chemical reaction, how do we represent it? It is represented in form of a chemical equation. It is represented in form of chemical equation. Now, this is a classic example of chemical equation. The simplest reaction is this: hydrogen gas reacting with oxygen gas, leading to formation of water. So a chemical equation is a written representation of a chemical reaction. And a chemical reaction can be balanced. Now, this is an example of balanced chemical reaction. But if I have to write it in unbalanced form, in the simplest form, I can simply write hydrogen. You know, hydrogen is in form of H2 gas, and oxygen, you do not find it in atomic form. Simple atomic oxygen would be this, but you do know oxygen can only be seen in air as a molecule, O2. Now, this leads to formation of H2O. This is an unbalanced equation. Now, to balance it, I simply have to ensure that the law of conservation of masses is followed, meaning the amount or the number of atoms towards the LHS or towards the reacted side should be equal to the number of atoms or mass towards the product side as well. Now, how do I balance it? I simply write 2 here and 2 here. Now, this equation I already know, but a balanced chemical reaction is one reaction where it follows law of conservation of masses, because mass can neither be created nor be destroyed on the reactant side, on the product side, both the sides, it has to be exactly same. One of the examples is again written here. Zinc, when added to sulfuric acid, it leads to formation of zinc sulfate and hydrogen gas is released. This is the simplest balanced reaction that we can see. But many a times we see that the reactions are unbalanced. How do we balance it? Again, I would say this is not very important from UPSC civil services perspective, but we do need to have some sort of a common knowledge about how do we balance an equation. One example is from this NCERT itself, where this iron and water reaction, it leads to formation of iron oxide 3 and hydrogen gas is released. Now, this reaction is unbalanced. Why? Because clearly you can see that on the LHS there is 1 iron atom, but on the RHS there are 3 iron atoms. Hydrogen probably looks balanced, but on the LHS there is only 1 oxygen atom, but on the right hand side there are 4 oxygen atoms. Now, how do you balance this? Step-by-step procedure is given. Let me just tell you in brief, and let me also give you some pointers with respect to balancing this. All right. See, first thing that you need to do is count the number of atoms on the LHS and RHS of different entities. There is iron, hydrogen, oxygen. So on LHS there is 1 iron, 2 hydrogen, 1 oxygen. But on the RHS, on the product side, the number of iron atoms are 3, number of hydrogen atoms are 2. So probably this is balanced. But to balance these two, we need to change something with respect to hydrogen also. 1 oxygen atom on the LHS side and 4 on the right hand side. So to balance, what you have to do is take the compound which has maximum number of atoms. It is the best way to proceed. So take Fe3O4, and when you take this Fe3O4, you will see, to balance this, on one side I have 4 atoms of oxygen. So add 4 wherever you find oxygen, you will see now the oxygen is balanced. Now to balance the hydrogen, I add 4 here also. Please remember, I do not change this subscript. Never change the subscript. Always change the coefficient. So the simplest way to do this is to ensure or find out odd and even on LHS and RHS. For instance, in this particular equation, if I look at iron, see, it has 1. If nothing is written, then coefficient is 1. There is 1 iron atom. There are 3 here. Both are odd. All right. With respect to hydrogen, there was H2 here. Let me go to unbalanced equation. There is H2 here. There is H2 on this side. Both sides even and balanced also. But when you look at oxygen, here it's only 1 oxygen. Here it's 4. So you will see that on one side there is odd number and one side there is even. So simply even out. Multiply one side with 2, you will get the idea. 2 or 4 with the even number, whatever is required. So what do? We multiply it by 4 to get a balance of oxygen. So similarly, we also balance hydrogen, and on this side it's the odd number itself. Use the same 3 here. All right. So these are the steps of balancing that have been given. Again, from exam perspective, as I told you, not very relevant from UPSC, but simply try to follow these steps. UPSC is unpredictable. So what you have to do, always remember, you have to adjust the coefficient, not the subscript, right? Now sometimes you might think that, okay, I'll simply change this 4 and I'll change something here. That cannot be done, okay? Against the rules of chemistry. So adjust the coefficient and ensure that look for even and odd and multiply by 2 to make even on either side. Wherever it is deficient, make even on both the sides. And if there is a polyatomic ion, especially like this nitrate ion, see, this is lead nitrate. If it is a polyatomic ion, then ensure that you balance it as a whole on either side, on LHS and RHS as well. And finally, look for the balance of the equation, because it has to follow the law of conservation of mass. Clear? Right. After understanding the balancing of chemical equations, let's talk about different kinds of chemical reactions. Now, we have discussed some of these reactions before as well. Generally, there are 4 different kinds of reactions that we find from the NCERT book also. The first reaction is the synthesis reaction, or it is also called as combination reaction, where 2 atoms, 2 molecules, they combine to form a compound. Another reaction is decomposition, meaning one particular compound breaks down into its constituents or different other molecules. Then there is a reaction of single displacement or single replacement and double displacement or double replacement. Let's try to understand these reactions one by one. First one, simplest, is the combination or the synthesis reaction. Now we see so many combination synthesis reaction in our everyday life also. Combination means there are 2 reactants which combine to form a product. Simple one, sodium and chlorine, they combine to form salt, sodium chloride. There are so many examples of combination reactions. The hydrogen combining with oxygen to form water, again combination reaction. Carbon with oxygen to find carbon monoxide with oxygen to form carbon dioxide. Sodium plus chlorine, sodium chloride. So we find so many combination reactions in our general life. But more than combination, I would say we look at many decomposition reactions. Decomposition means a single or a compound breaking down into different products, right? See, for example, carbon monoxide into carbon and oxygen. A compound, right? Calcium hydroxide into calcium oxide and water. There can be many examples. For instance, the simple digestion process is a decomposition reaction itself, where the constituents are breaking down. Carbohydrates, polysaccharides breaking into monosaccharides, monosaccharide breaking into ultimately the elements. So there can be many decomposition reactions. The examples are here. Water molecule breaking into hydrogen and oxygen. Again, there are certain rules that you need to remember. Generally, I have written generally here. Generally, decomposition reactions are endothermic. There has to be some sort of activity which occurs, or the reactants undergo some sort of change because of an agent. I have written generally here. There is a possibility that some decomposition reactions can be exothermic as well. And the corollary of that would be, generally combination reactions are exothermic. Whenever 2 things combine, then energy is released. Again, in general, there can be some endothermic combination reactions as well. Now, as I told you, decomposition is very common. Decomposition can be thermal decomposition. You simply heat a compound, it might break into constituents. There can be example of photo decomposition. You keep something in sunlight. You keep something in sunlight, and because of the light, there can be decomposition. For example, silver chloride. If you keep silver chloride in your window, then the chlorine gas is released slowly and steadily. There can be a possibility of electrolytic decomposition also. You apply it, the EMF, or you apply some electromotive force, and then decomposition can occur. The compound might break into its constituents. Apart from combination or synthesis and decomposition, there are two other reactions, displacement and double displacement. We call it replacement and double replacement also. It's a reaction where one atom, it replaces another. Now, general reaction is this: A plus BC. Ultimately, the product leads to AC plus B. There can be many examples. For instance, in sodium chloride, when potassium replaces sodium, it leads to potassium chloride, and then sodium is released. This is single replacement. And double replacement is when the cations, they exchange each other. That means the general reaction would be AB plus CD. It leads to AD and CB. A and C being cations and B and D anions, that is negative ions. One of the examples is here. AgNO3 plus NaCl, it undergoes a double displacement or double replacement. Na is replaced by silver, and the other anions are also replaced. All right. So reaction can be combination reaction, decomposition reaction, double displacement, or single displacement. Now, apart from that, it can be oxidation or reduction reaction. Now, the general understanding or general form of oxidation is something combining with oxygen is oxidation reaction. For example, one of the ideas is given here that if copper oxide, it reacts with hydrogen, it leads to formation of copper and water is released. This is a reaction which is given here: copper mixing with oxygen leading to copper oxide reacting with hydrogen leading to copper and hydrogen. So the understanding here is whenever a substance gains oxygen, it is called oxidation reaction, and whenever a substance loses oxygen, it is called as reduction reaction. So when I say gaining oxygen or losing oxygen, it can also be explained through a corollary of hydrogen also. That is what is explained here. Please remember, oxidation reaction means whenever a substance gains oxygen or loses hydrogen, it is called as oxidation. So let me just write here: oxidation is a process which leads to gain of oxygen or it leads to loss of hydrogen. And the reverse can be explained, right? If it gains hydrogen, if it loses oxygen, that becomes your reduction, the corollary of that. Apart from this, there is also an example of redox reactions. Now, redox reaction, they are not peculiarly connected with oxygen hydrogen, but we can explain using that logic also. In general, in a redox reaction, whenever there is a loss of electrons or whenever there is increase in the oxidation number, that process is called oxidation. Please remember, oxidation is equal to loss of electrons and reduction is equal to gain of electrons. There can be many examples of this redox reaction. For instance, here if you see sulfur dioxide and oxygen leading to sulfur trioxide, example of redox reaction. So remember this, oxidation means loss of electrons or increase of oxidation number, and reduction means gain of electrons. Now, apart from these reactions that we discussed, there can be many other reactions which can be explained. Now, we already discussed about decomposition, meaning one compound breaking into its constituents or other molecules. We have also discussed about addition or synthesis reaction. There can be displacement, single displacement or double displacement, oxidation reaction, reduction reaction, redox reaction also we have discussed. Apart from that, reactions can be explained as combustion. Now, combustion, again, simple kind of a reaction where something reacts with oxygen to give you energy, heat and light. There can be precipitation reaction, change of state. We saw some examples. Condensation, where again change of state, something is condensed, or it can also be hydrolysis, water breaking into hydrogen and oxygen. This is just for your information. Apart from that, a very important information from NCERT is this. When a solution of slaked lime is produced by a reaction and it is used for whitewashing, that is, you use calcium hydroxide, it reacts very slowly with carbon dioxide in air to form a very thin layer of calcium carbonate. And that calcium carbonate itself, it gives you a finish when you do a whitewash, right? When you do a lime wash or a whitewash on the wall, the ultimate product would be calcium carbonate. Slowly and steadily, the calcium hydroxide is basically used as paint, and it is painted on the walls, and it reacts slowly with carbon dioxide, giving a very shiny finish to the walls. And please remember that it's very interesting to note that even the formula for marble is also CaCO3, calcium carbonate itself. Clear? Now, apart from this, chemical reactions, as I told you, they are a part of our everyday life. You must have observed these things. Whenever there is oxidation reaction which occurs in our everyday life, one of the examples is corrosion or rusting, where iron, it slowly and steadily accepts oxygen, leading to formation of oxide, iron oxides, which is rust, reddish in color. Apart from that, another example is rancidity. Now, rancidity is generally observed with oil and fat. You must have seen, especially when you open an old packet of, say, chips, an expired packet of chips, you will feel the rancid smell, where the fats or the fatty acids or oil, they are oxidized, and because of that, the taste changes. Their taste changes, they become rancid. Its smell also changes, and it is not good for your health. That is why whenever something is fried, oily stuff, it is kept in airtight box. It will remain for a longer time. For instance, your chips packet, it is completely sealed. As you open it slowly and steadily, the fatty acids, they react with oxygen and they turn rancid. The taste also changes, the smell also changes. You should not eat it. All right. So that's why I told you chemical reactions are seen in your day-to-day life as well. Right. So that's basically the first chapter of our class 10. Let me end our discussion with a sample question for you. If I remember it rightly, I think this is the question from Civil Services Prelims 2014. I wouldn't say this is a direct question which is connected to chemical reactions, but these are the kinds of questions that appear in UPSC Civil Services examination, where you need to understand the differences between physical change and chemical change, meaning of chemical reaction. There is no concept of balancing the equation, but the question simply asks you which of the following is an example of chemical change or some sort of chemical reaction. Crystallization of sodium chloride, melting of ice, and souring of milk. Now, if you try to analyze what is happening here, it is asking you the example of chemical change. When sodium chloride crystallizes, is there any chemical change which is occurring? No. Sodium chloride or salt, when mixed with water, it will dissolve. You simply boil that water, water will become vapor and it will go off, and the salt will remain as it is. So there is no chemical change. Similarly, melting of ice, it is not a chemical change, it is simply a physical change. But when the milk is soured, milk becomes curd, buttermilk, then some sort of chemical change has occurred. So the answer for this would be 3 only. Such questions do appear in UPSC Civil Services examination. So do note that you may not get a direct question, say, about a chemical reaction or something, but connected to these concepts, questions can be created. All right. Right. So that's the end of today's discussion. And again, thank you very much for watching. And if you like this video, then you can always follow me on this particular ID, Rahul Sai 222. I will be also posting the link for the playlist on this particular ID itself. Thank you again. Jai Hind.